Okay, so this is going to be going over the notes that we did on Friday. It's going to be lesson 7, day 1. We're going to be going over how to categorize our data and make our exponential equations that we worked on. So I'm going to be doing the same notes. I'm also going to go through 1 or 2 of the practice questions as well in case you got super stuck on any of those in class. So remember, for classifying data sets, we have 3 that we're looking at right now: linear, quadratic, and exponential. So, quadratic functions, they have a constant second difference. Now, exponential data has a common ratio. So whenever you think of ratio, you should think of like multiplication. So because it's defined by multiplication, that means if you're noticing a pattern of division, you actually need to write whatever the reciprocal of that number is. We'll look at one practice problem that had that down farther in the notes. So for example 1, we're classifying our data sets. It says determine the function represented by each table. So what I'm going to do is I'm going to try and look for some patterns here. So if I'm here, I'm like, okay, it goes from 0.5 to 1, to 2 to 4 to 8 to 16 and then to 32. So as I'm looking at this, I'll notice like, hey, that's times 2. Oh, that was a times 2 all the way down. So the way I'll help myself write this out, I'll be like, oh, at times 2, you can either use the x, or if you prefer, the dot times 2, times 2, times 2. And if that's true for each of these, that's going to be what we call that common ratio. So whenever we see a multiplication or division that's constantly going across, we'll say, oh, we have a common ratio, meaning we have an exponential function here. So then for B, I have here a little bit of a different pattern going on. I can't see anything for multiplication because this would be times 0. Here, there's no multiplication that can make 0 a 2. Here then, 2 to 8, that's not really a nice number to multiply by. I don't really see anything here. I don't see any patterns just yet. So what I'm going to do, if I don't see multiplication or division, I'm going to go through and I'm going to find the difference for each of these. So to get from 2 to 0, I would have to go down 2, so I'm going to write a minus 2 here. 0 to 2, I would need to increase by 2, and we're going to do that just all the way down. I would need to add 6. Sorry, I was going to write a 4 for a second there. Add 6, add 10. So here, we're adding 14. And then 32 to 50, we're going to be adding an 8. And then that would make that 40, so an 18. So what I'm going to do is I'm going to look here and I'm going to say, okay, none of those had a constant difference, so let's look at what their differences are. Well, to get from negative 2 to positive 2, I would have need to go up by 4. 2 to 6, up by another 4, 6 to 10, up by another 4, to 14, up by 4, and to 18, up by 4. So as I'm looking at this, I'm noticing, hey, these are all increasing by 4. So here, my first difference, well, was all different numbers. 2, negative 2, positive 6, 10, 14, 18. But here, since they're all plus 4, my second difference here is constant. So we have a quadratic. So what you're looking for really as you're going through these is you're going to go, okay, first check, is it exponential? You're looking for multiplication or division. Next, you're saying if I don't see any of that, we're going to see if it's linear. That would be that constant first difference. Well, if there's not a constant first difference, then we're going to go and we're going to find the difference between those. then we would have our quadratic. So constant second difference here. So I highly recommend pausing this to try the practice if you haven't already. Otherwise, I'm going to be going through this and you can follow along with me. So for these ones, we need to explain our reasoning. So this is really going to help increase that understanding of how these are working and be able to make it so we can do this when we're tested on it or need to do it outside of our practice on homework. So first thing I'm going to say, okay, 15 to 12, there's really no good division here to get between each of these numbers. But what I could do is if I look here, oh, this reduced by 3, reduced by 3, and reduced by 3. So I'm going to say this is a linear function then, because we're really going to make sure to use our vocab for this reasoning, because the first difference is a constant change by -3. Now for 2 here, okay, I'm going to look for division. Well, I know here I could divide by 3. Here, oh, I could also divide by 3. And then divide by 3. The reason I was looking for division was because my numbers were getting smaller in my y values. Now, if these are all divided by 3, that's going to be exponential. And we're going to say that's because there is a common ratio. So making sure to use that vocab word here, common ratio of, but instead of saying 3, because remember we're saying common ratio we multiply by, of 1/3, that reciprocal here. So our next set of notes is going to be focused on writing those exponential functions. So if you still want more work on the classifying data sets, go ahead and look at that homework and try some of those problems now. Alright, so writing exponential function using 2 points. So we're going to be doing this in our calculators later on, but this is going to be teaching us how to do these by hand with 2 points. So what we're going to do first, step number 1, is to create 2 equations by plugging in your points to general formula. So if we look here, it says you're writing an exponential, and it gives us this form. So whose graph passes through point number 1, so here, and point number 2 here. Terrible one. Okay, so my first equation then, I'm going to have my y value, so 6 is equal to a times b raised to the x. Well, my x value is a 1 here, so I'm going to fill that in. Now we'll have 2 equations that we're making, because I have 2 points. So I'm going to have also a 54 is equal to a times b, and that's going to be cubed. Now that I know this, step number 2 is going to be to solve for a, and we're going to say in equation 1. So I'm always going to label equation 1 as the one with the smaller exponent, so whatever one has the smaller y value will be equation 1. So smaller, or not y value, sorry, smaller x value. That's just going to make our solving a little bit easier as we move forward. So step 2, solving for a, this was step 1 here. Step 2, what I'm going to do in order to solve this for a is just divide by a b. Because I have 1b up top, I'll divide by 1b on bottom, that means these cancel out. I'll have 6 over b is equal to an a. So step 3, what we're going to do is we're going to substitute a into equation 2 and solve for b. The nice thing about once we have our b value is that makes it really easy to find our a value because it's already in terms of it over here. So once we solve for b, find a. So plugging this in here, that's step 3. So 3 is to plug in. So what that's going to look like is a 54 is now equal to, instead of writing a, I'm going to put some parentheses and plug in that 6 over b times b cubed. So here, these b's are going to cancel each other out a little bit. So our rule says we subtract our exponents, so we'll have a 6b squared, because there's technically a 1 here. 3 minus 1 is 2. If you're still a little rusty on your rules, the reason that works out is because, remember, b cubed is a b times b times b divided by 1b. Well, these are canceling, leaving a b times b behind, or that b squared that I wrote over here. Last solving steps, I would sorry about that. I would divide by 6. So I'm going to end up with 9 is equal to a b squared. Then you're taking that square root on both sides. By doing that, we'll end up with a b is equal to 3. So now that I have b, we're going to follow the rest of that step step 3 and find a. So now I'm taking this and I'm plugging it back in over here. So we'll have a is equal to a 6 divided by b. Well, now I'm plugging in that 3 value, giving me a is equal to 2. Now that I know a and b, I'm basically done. All I have to do is plug them in. So I'm going to do that right over here. We're going to have y is equal to a 2 times 3, times 3 to the x. So I'm replacing my b with 3, my a with 2, and my x and y will still stay in my equation. But if I plug these points in, they should work out. They'll end up being equal to each other on either side. So at this point, if you haven't yet, I recommend going through and trying these practices. I did question 1 in class, so I'm actually going to go through 3 in the video here. So here we have a 2, 16 and a 5, 12. So I'm going to make that first equation. I'm going to have 16 is equal to a times b squared. And my second equation will look like a 5 is equal to an a times b, 2 is equal to an a times b to the 5th. So what we're going to have here is we're going to take this and solve for our a. So divide by your b squared. Make sure whatever your exponent is here, you're carrying through to that other side so they actually cancel. So a is equal to a 16 over b squared. I'm going to plug that in now. So I'll have 2 is equal to a 16 over b squared times ab to the 5th. Now, once again, we're subtracting those exponents just like we did up here. So we'll end up with a 2 is equal to a 16b cubed. So if I divide that 16 over, these are actually both divisible by 2, so we'll end up with a 1/8. So I have a 1/8 is equal to a b cubed. So to get rid of that exponent of 3, we're doing that cube root of both sides. These will cancel each other out then. Well, we don't like fractions very much, but I do know that 2 cubed is 8. So if 2 cubed is 8, 1/2 cubed would be 1/8. So 1/2 here is going to be equal to our b value. So now that I know my b value, I'm going to take that, plug it back in up here to find my a value. So a is going to be equal to a 16 divided by a 1/2 squared. So remember, whenever I divide by a fraction, it's technically dividing here, but we'll switch it to multiplication by multiplying by the reciprocal. 1/2 squared will be a 1/4, so we'll end up with a is equal to a 16 times 4 instead. So we should have an a value equal to 64. Now that I know a and b, we're going to plug that into our equation over here. Y is equal to a 64 times, and since it's a fraction, I'm going to put it in parentheses, 1/2 to the x. At this point, this is everything we covered on Friday. So you should go in and work on that homework here. Example 3 is all about finding an exponential model from a table. So we're actually going to be doing the same process as example 2, but with a real life problem now. So we'll be doing these notes on Monday. So if you don't want to get ahead, go ahead, stop the video here, work on homework. So, a store sells trampolines. It's going to be a common theme of our notes for this next week. And it says this table shows the number of trampolines sold, that's our Y value, during the Xth year that the store has been open. Write a function that models the data. So if I want to write a function that models the data, first thing I need to figure out what type of function would actually model this. If I look here though, 12 to 16, that's a difference of a +4. Well, here it's a difference of 16 to 25, that's a +9. We've got a +11. But here it jumps up a bit. We have a +14, +17, and a +19. Yeah. No, +29. Yeah, +29. Sorry. Brain's working great. I'm still sick. Okay. If I look at this, my second difference isn't going to be constant as well because it's going to be increasing still. Because this is, well, here was a +5, 9 to 11, that was a +3. Here, or sorry, not +3, +2, +3, +4. But then here it jumps up to a +12. So that's not very consistent, and it's getting larger technically as we go up this line. So if it looks like it's continuing to grow and grow and we look at these differences, what we actually need to think is like, okay, this is probably going to be an exponential model, even though it's not easy to see what a multiplication might be between these. So what we're going to do is we're going to say, okay, it keeps growing. So what we need to do is exponential. We're just going to follow the same steps as above. We're going to pick 2 points this time though. I always like using 1, so 1 and 12 from there. You could pick any other point, it doesn't really matter. To keep my numbers kind of nice, I'm going to do 3 and 25 here. So now that I have 2 points, I have 1, 12 and 3, 25. I'm going to make my equations. Okay, so my first equation here, it's going to look like A12 is equal to A times B to the first power. My second equation will be 25 is equal to an A times B cubed. Once I'm here, I'm going to go in and I'm going to say, alright, I want to solve for my A first, divide by B on both sides, that cancels. A is equal to 12 over B. Over here, I'm plugging that in now. So I'll end up with a 25 is equal to 12 over B times a B cubed. When I subtract these, we'll end up with B squared, just like we did in our first example. But now I have 25 is equal to a 12B squared. So at this point, we're not going to end up with super nice numbers because it's a real life problem. So I'm going to have 25 twelfths is equal to a B squared. So from here, we would have to take a square root. These will cancel. We'll have B is equal to the square root of 25 over 12. Well, this can simplify some because 25 has a square root and 12 is also divisible by 4, which has a square root. So to simplify this down, we would actually end up with a 5 on the top over a 2 root 3. Last thing is to rationalize it. We don't like having radicals in the bottom, so we would have a 5 root 3 over 6 if we multiply by root 3 on the top and the bottom. If this were a calculator problem, you could go through and just find a decimal approximation here. It's unlikely that we would ask you to do something like this with these numbers on a test. So now we're going to find our A value. A is going to be equal to A12 divided by B. So remember, division is the same as multiplication if I do the reciprocal. So we have over 5 root 3 over 6. So I'm multiplying by this fraction that I put on the bottom instead. So we'll end up with A is equal to A12 times 6, which is 12, carry the 1, 32. No, it's not. 2, carry the 1, 6, 72. I can't math today. Divided by 5 root 3. Last thing is to create that equation. So we'll have y is equal to a 72 divided by 5 root 3 times, and over here we're going to have a 5 root 3 over 6 to the x. Because of this exponent, you cannot cancel these out. Be very careful here. Following GEMDAS or PEMDAS, whichever you prefer, this exponent is attached here. Sorry, you can see that. This exponent is attached, so we can't go forward to our next step of multiplication. We can't go here yet because of this exponent. So go ahead and try the practice if you're feeling confident. We'll be going over this more in class next week.